As I mentioned when we began Chapter 4, this chapter is quite the hodgepodge of various topics. In the first section, we talked about how to take nonlinear data and transform it to achieve linearity. And in the second section, we are not going to talk about anything that is even remotely related to transforming data. What we're going to be talking about here is how we can organize categorical data so that we can learn a little bit about how the data is distributed, and then we can make comparisons between various categories. So first of all, we need to recall what a categorical variable is. We talked about that in Chapter 1. And a categorical variable is simply a variable that describes data that falls into various categories. Gender is one example. I think back in Chapter 1 we gave an example of eye color. You could say level of education, nationality, all sorts of different categorical variables are possible. For this particular section, we're going to talk about three things that are related to categorical variables. We're going to talk about two-way tables, marginal distributions, and then conditional distributions. And I think the easiest way to understand this is just to look at an example. So this is some data that I found in a statistics textbook where a group of young adults was surveyed and asked about what they thought their chance of getting rich was at some point in their life. So there were 5 different opinions that they could state, ranging from having almost no chance to almost certainly being rich within their lifetime. And then those responses were broken down by gender. And then that data was taken and organized into the table that you see. So the first thing that we want to talk about, our first topic, is that of a two-way table, which is exactly what we have here. It's called a two-way table because we have 2 different categorical variables that we're looking at. We have the category of the various opinions that could be expressed, and then the category of the 2 genders that each respondent could have. So then once each person responded to the survey, their response would be recorded into one of the cells within this two-way table. Any female who said that there was almost no chance of becoming rich, their response would be recorded in this cell. Any male that said that they would almost certainly become rich would be recorded in this cell, and so on and so forth. So this table does provide a nice summary for how all of the responses shaped out. So a few things to notice. First of all, of course, we're just looking at the counts here, the counts of all the people who responded to the survey in various ways based on their gender. And then we also have in the final column, in the final row, we have the totals for each of the categories. So we have the total number of people who said that they had almost no chance of being rich, and then same for all of the other possible opinions. We also have the total number of females and the total number of males who responded to the survey. One last thing to notice about this two-way table is that down here in the farthest right cell, we have the overall total. This gives the total number of respondents to the survey. And for any two-way table, there will always be 2 ways to calculate this number. You can either add up all of the columns, all the rows above that value, or you can add up the columns to the left of the value. As long as you've done everything correctly and entered your data in appropriately, you should get the same sum either way you add it up. Now, within our two-way table, we actually have several different marginal distributions that we're looking at. So let me get rid of that. So our next topic, marginal distributions. And a marginal distribution simply gives you the distribution by count for your various categories. So for instance, here we have the marginal distribution of all the female respondents. We can see exactly what their counts were for each of the possible opinions. We also have the marginal distribution for the male respondents. So if we're looking at gender, we have 2 different marginal distributions that we can examine. If we're looking at opinion, though, we actually have 5 different marginal distributions that we could look at. because there were 5 different opinions that could be given. So we're looking at across the rows that way. Now you might have already thought about this, but looking at just a marginal distribution, though it is helpful to see the counts, it doesn't give you a very useful way to make comparisons both within the distributions for each category, and also if you want to make some observations from one category to another. So instead of using a marginal distribution, what we need to do is use a conditional distribution. To go from a marginal distribution to a conditional distribution, all we need to do is convert our counts into percentages, because percentages are much easier to compare because, of course, they're out of just 100%. For any two-way table, you're always going to be able to look at conditional distributions in 2 ways. And so for this example, we're going to look at both of the possible conditional distributions. So the first one that we're going to look at is the conditional distribution of opinion by gender. So notice now, instead of having counts in each of our cells, we've got percentages, as I mentioned. And we'll talk just in a minute about how to get each of those percentages. But what I want to point out first is the fact that now that everything has been converted to a percent, it's quite a bit easier to get some information about this categorical data. If we're looking at the column with the female data, we can quickly see that the greatest number of respondents said that they thought they had a 50-50 chance of becoming rich within their lifetime. But quite close to that was those who said they had a good chance. So most of our data for the females is clustered around these 2 responses. Very few were pessimistic about their future and said they had almost no chance. And about 1/5 of them actually said that they were almost certain that they would be rich within their lifetime. So you can easily see how the data is distributed within the gender for female. Same thing with the males. You can take a look at how their responses are distributed. Much like the females, there's a good chunk of them who either said they thought they had a 50-50 chance or a good chance of becoming rich. Quite a lot of them also thought that they were almost certain to become rich, and very few of them said that they had almost no chance. So within each of the individual genders, you can make some observations about how the data is distributed. Another helpful thing about conditional distributions is that we can now compare the responses across the 2 genders. Notice we can make a comparison here. Just about the same percentage of females and males said that they had almost no chance, right around 4%. There's a pretty big gap, though, when we look at the next response. 18% of the women said that they thought they had some chance of getting rich, but only 11.63% of the men responded that way. So it looks like maybe the men are a little bit more optimistic about their futures. Let's keep going down. Notice almost an identical percentage of men and women said they thought they had a 50-50 chance. Slightly more men than women thought they had a good chance of becoming rich. And a relatively significant percentage of men over the women said that they were almost certain. Only about 1/5 of the women said that they were almost certain that they would become rich, while just about 1/4 of the men responded that way. So again, the reason that conditional distributions are so helpful is because not only can you make observations within your categories about how the data is distributed, you can also make comparisons across categories. Something else to point out, you'll notice that now in our totals, down at the bottom for the genders, we have 2 100% values. And hopefully that's pretty easy to figure out where that came from. You just add up the percentages for all the female respondents, and as long as you've accounted for everybody's response, it should add up to 100%, and same with the males. But across the rows, you'll notice that the totals don't say 100% over here, and you need to be careful. It might be tempting to add across the rows, but if we added about 4% and about 4%, then over here we would have 8%, which is not what we have if you notice. Here, if we added across the rows, we'd have 18 plus about 11%, so that'd be around 29%. Again, not what we have. We only have 14% in this column. So we need to talk in a moment about where those percentages are coming from and how to calculate them. But first, I want to talk about where each of the individual percentages are coming from. For instance, how we got this percentage of 4.06 for the women who said they had almost no chance. To get that value, what you'll need to do is go back to your TwoWay table, and you're going to look at the number of women, the count of women who responded to having almost no chance. And then all you simply need to do is divide that by the total number of women who responded to the survey. So when you do 96 divided by 2,367, you get 4.06%. Now if we go down to the next row, we got 18% here, and that comes from taking 426% and dividing that by your total. And so you just progress through your table exactly the same way. And once you finish with one category, you just have to move over to the other category. And for instance, the first entry for the men will be 98 divided by 2,459, and that's where this 3.99% comes from. So getting the percentages in the body of your table, that's pretty self-explanatory, not too difficult. What is just slightly tricky, it's not too difficult, you just have to remember how to do this, is to get these total percentages over here. Again, you do not add across the rows. That is incorrect. What we're going to do instead is we go back to our original table, and made a mess of this, you are going to add together the counts of both of your genders that responded that they thought they had almost no chance. And then you divide that by the total number of responders that you have. So you add again 96 plus 98, and then you divide that total by 4,826, and that's where we come up with the percent of 4.02%. So 4.02% of all respondents said they thought they had almost no chance of becoming rich. And then to get those who said some chance but probably not, you do the exact same thing. We would add 426, 286, and then divide by 4826. And then you add your way on down. Now, one other thing to notice about this conditional distribution here is that we do end up with 100% in our bottom right cell. Obviously, that's not the addition of 100% plus 100% across the rows. That doesn't really make much sense, because that would be 200%, and that doesn't mean anything. This value here, this 100%, just comes from summing up all of these percentages, and that's just in there to make sure that you have accounted for everything. If it doesn't add up to 100%, you've probably made a mistake somewhere. Now, that being said, because we're dealing with relatively large numbers, ranging from, somewhere in the 90 range all the way up to 760 or so, you're not going to get really nice, even percentages when you do these calculations. And so if you end up having to round, which you are almost sure to have to do in the body of your table, when you go to add up those percentages, you may not get exactly 100% depending on how you have rounded. So if you end up with, let's say, like 99.7%, that doesn't necessarily mean you've done anything wrong. It just might mean that because of the way you rounded, a very small percentage of your data was lost to a rounding error. And that's not a particularly big concern that you should be worried about. Okay, so we've looked at one of the two possible conditional distributions from our data. We've looked at the conditional distribution of opinion by gender. The last thing we need to do here is to look at the conditional distribution of gender by opinion. So notice we're just swapping these two words, And by swapping the way we refer to this distribution, that's going to completely change how our data is presented to us. Instead of looking at our data based on the two genders, we're going to look at our data based on our 5 different possible opinions. So let's take a look at this table. Again, notice the percentages in the body of our table are completely different than they were on the last slide, and that's intentional. Now we are looking across the rows instead of down the columns. So let's take a look and see where this 49.48% came from. Just like we did before, we go back to our original table. Get rid of all this stuff. Go back to our original table and we look at this value of 96. Now last time, to get our percentage in that first conditional distribution that we looked at, we got 4.06%. To get that value, we took 96 and we divided it by 2367. Not so now. This time we want to take 96 and divide it by 194. And when we do that, we get 49.48%. It shouldn't be much surprise that when we then look at the male data that corresponds to the female data for this category of opinion, we take 98 and divide that by 194, we get 50.52%. And then notice when we add these percents across the rows, now they do add up to 100%, all the way down. But if you'll notice down here, these percents are no longer 100%, but they do add up to the 100% in our bottom right cell, which should make some sense. And then the way we get this 49.05% and the 50.95% is we go back to our original data and we're going to add up the total number of our female respondents. So you can either sum up everything in the body of this table or you can just take this number 2367 and we're going to divide that by the total number of respondents, which is 4826. So 49.05% of our respondents were women, 50.95% of our respondents were men. So we did have slightly more men than women. And also from here we can say a little bit about how the two genders and how their responses compare to each other. We're looking at the data in just a slightly different way than we did before, because we're looking at each of the opinions separately. So now we can clearly see that almost 60% of the women said that they thought they had some chance, but probably not. Excuse me, I take that back. 60% of the people who said that they had some chance, but would probably not become rich, were women, whereas only 40% of people who said that were men. Excuse me, I said that incorrectly to begin with. But what this does, looking at the data this way, allows us to just see how different the distribution between the two genders is for each opinion type. And I think that's about it as far as conditional distributions go.